The next topic and the last topic for this module is analysis of systems that include frictional forces. So this topic should be familiar to you guys because it's the same topic in your physics classes, friction. Okay, so as usual, introduction. So friction is basically just the contact resistance exerted by one body when the second body moves or tends to move as the first body. Okay, so this means for friction to be present, we don't necessarily need moving objects. Okay, we can just have impending movement or motion that tends to move, meaning it's about to move. Okay, so there's still friction in that. It doesn't have to just move. That's why we have your static and kinetic friction. Friction is also a retarding force that always acts opposite to the motion or to the tendency to move. So pretty basic stuff from your physics classes. It's just a review. Now, to further specify, we have these types of friction. First is your dry friction. It's also called your Coulomb friction. It occurs when unlubricated surfaces of two solids are in contact and slide or tend to slide from each other. Now, if lubricant separates the two surfaces, we have a different friction. The friction created is called lubricated friction. Okay, so there's a difference. For our discussion, we're only focusing on dry friction. Okay, so whenever we're talking about friction, this is the type that we're talking about. Now, the other types of friction are fluid friction. Fluid friction occurs when layers of two viscous fluids moves at different velocities. Okay, so it's the same type of fluid, it's just moving at different velocities. Now, the relative velocity between the layers causes the frictional force between your fluid elements. Therefore, if there's no fluid or rather, there's no fluid friction that will occur if there's no relative velocity, meaning the entire body of water has the same velocity. There's no friction then. Okay? So, in the presence of different velocities, we have fluid friction. The third type of friction is skin friction. It's also called friction drag. Okay? It's a component of the force resisting the motion of a solid body through a fluid. Now, drag is also one of the topics that you'll talk about more in hydraulics classes, okay, or fluid mechanics class. If you're taking that, you'll talk more about drag, which is basically just friction in water. Now, this is different from fluid friction because fluid friction is friction between two fluids. Skin friction or drag is friction between a solid body and a fluid. Okay. And then lastly, we also have internal friction. It's associated with shear deformation of the solid material subjected to cyclical loading. Cyclical loading is just load that operates cyclically, or rather, there's a pattern to which the force is being applied. So you can imagine if we have a continuous force being applied to an object, eventually it's gonna experience your shear deformation. Okay, and then as deformation undergo during loading, internal friction may accompany that deformation. So as your shear deformation happens, and remember, shear is when two objects slide past each other. And friction happens whenever you have two objects in contact that are moving or tends to move. Hence, friction is also involved when we have shear deformation. Okay? Well, again, the focus of this topic is dry friction. So we have the following. Right? Consider this figure or this box resting on a surface. Okay? So this box has weight, and there could be an applied force F on this box as well. Now remember, whenever we have two objects in contact, we have normal force. Normal force is just the perpendicular force to the surface in contact. Now, if this surface is not frictionless, obviously you'll have friction, and this friction will oppose the motion or tendency to move of the object. Now, because of the presence of this force to the right, it's safe to assume that the motion of this object would be to the right. Friction opposes that, so friction is to the left. Okay? Then we have the following equations. So let's talk about how those equations came to be. Okay. So according to laws of friction, friction is actually directly proportional to N. So F directly proportional to N. And remember from your math class, how do we get an equation out of that? You're gonna introduce a proportionality constant, either, or it's usually K, right? But for friction, that value is not K, it's mu. And that's how that equation came to be, where mu is coefficient of friction. Okay, so that's how we got F equals mu N. Now, how about the following equations? Tangent phi equals F over N. So let's take that figure, right? So again, we have this figure. We have an external force. There could or could not be an external force. Okay, friction will still happen. The weight, this has a weight. Then whenever again two objects are in contact, there's normal force. This is your N. This force will make your object again move to the right. So to oppose that, we have frictional force. Okay, so these two forces creates a resultant. Okay, so the direction of the resultant is somewhere here. Okay, again, this R is the resultant of your normal force and your frictional force. And then the angle between them, this is your phi. Okay, then you've noticed, okay, whenever you have a resultant, remember, it creates a right triangle. So just considering this right triangle and using trigonometric function tangent, tangent phi is opposite over adjacent. This is the opposite, which is also equal to this line, which is F. So F over adjacent this line, which is there. That is how tangent phi equals F over N came to be. Now tangent phi equals U because if we move this around, mu equals F over N. So sub that here. Tangent phi is also just equal to mu. Okay, so this means if you have, or if the coefficient of friction is given, it's easy to figure out what this phi is. And phi is your angle of friction, which will come in handy in determining whether is your object moving or is it stationary. So again, angle of friction is helpful to determine if it's moving or not. So let's consider the block shown to the right that weighs W. It is placed upon a plane that inclined at an angle theta with the horizontal. So you have this plane, this is your theta, and again, phi is the angle between your normal and your resultant. Okay? You already know how to solve for phi. So if phi is less than theta, the maximum available friction force F is less than W sub x. Thus, the block will slide down the plane. So W sub x, right? If we rotated our axis, if we consider the x-axis as the same axis as your incline, right? So W sub x is a component parallel to that. F is also parallel to that. So if we do summation of forces x, right, W sub x would be greater than your F. Okay. So W sub x, which is always downward, greater than F, therefore the tendency of your object is to slide down. So since it's greater, it will slide down. So thus, the block will slide down the plane. Okay. Now, if phi is equal to theta, the friction force F will just equate to W sub x. Thus, the block is impending motion down the plane. So W sub x equals F, it's an equilibrium. So there's no motion. However, for friction, there's the presence of friction. You don't just say it's an equilibrium or it doesn't have motion. We say it's impending motion down the plane, meaning any additional force will make your object move, okay? Specifically downward. And then if phi is greater than theta, the maximum available frictional resistance F is greater than W sub x, thus the block is stationary. So now, force, your friction is greater than your W sub x. Again, W sub x is the force that will make your block slide down. Since friction now is greater than that, it can oppose that motion. Since it's opposing that motion, it's stationary, okay? So in contrast to impending motion means the smallest amount of force will make it move. Okay, here, stationary just means not moving anymore, okay? So those are our cases. Again, phi less than theta, slide down. Phi equals theta, impending motion. Phi greater than theta, stationary. So we can therefore conclude with the maximum angle theta that a plane may be inclined without causing the body to slide down is equal to the angle of friction, P. Okay, so if ever the question is how high, how how high the incline, how high can we make the incline of a structure before it slides down? So the answer to that would be your angle phi. Okay. Now we have the following laws of friction. First, if friction is neglected, the reactions are always normal to the surfaces in contact. Okay? Meaning there's no frictional force. Next, friction always acts to oppose the motion of the free body, as mentioned earlier. Next, if static friction is acting, the value of the friction force may vary from 0 to the maximum available value. Okay? So, in short, static friction, depending on the situation, can vary. And then the maximum available value of static friction is equal to mu s n. Okay. Where mu s is your coefficient of static friction and n is your normal force. And then lastly, if kinetic friction is acting, the friction force is constant at its limiting value, and your kinetic friction is equal to mu k times n. Meaning, in contrast to static friction where it's varying, kinetic friction is the same, and its value is mu k, which is coefficient of kinetic friction times n. The static friction is what's present when your object is not moving, while kinetic friction is what's present when your object is finally moving. Okay, so that's the difference. So depending on the situation, we'll use either static or kinetic friction. Okay. So any questions so far before we move on to the examples? Okay, since you don't have any questions, let's have a few examples. So let's start with number 1. Again, I'm going to answer number 1. You just have to listen. I'm not going to take recitation yet. Okay. The 2,225 block shown in the figure is in contact with 45-degree incline. So 225 block, 45-degree incline. The coefficient of static friction is 0.25. Compute the value of the horizontal force P necessary to, letter A, just start the block up the incline. So impending motion up the incline. Letter B, just prevent motion down the incline. And then letter C, if P is 1,780, what is the amount and direction of the friction? So we're looking for three things. Let's focus on A, how much force needed to start the block up the incline or to make impending motion up the incline. Okay, let's begin. First, let's draw a free body diagram. Okay, so for letter A, again, the situation is impending motion upward. Okay, so just keep that in mind as we draw our free body diagram. Okay, so weight is always downward. So this is your 2,225 Newton. There's a force P here. Let's assume this force P is acting at the center of your block, since it's not specified that it's not, so we can assume that. Therefore, this is still a concurrent force system. Okay, again, P acting at the center. Next, what do we have? Normal force. And normal force is always perpendicular to your surface or surfaces in contact. So I can draw that here, but it looks a bit crowded. So instead, I'll just move it here. This is Rn. And what else? Remember, we have impending motion upward. Okay, so the tendency of this is to move upward for part A. Friction is opposing that, so it's gonna be downward. So if we draw that, it's gonna look something like this. And this is your, okay, so that's your free body diagram. Next, let's include your angle. Okay, so the angle between P and N is easy to figure out. Because remember, in our previous examples, we had something like this. If you want to go through the process, so create a straight line here. This is also 45 because they're parallel angles, right? This is 90 degrees. So 90 minus 45, this would be 45 as well. If I extend that line, right, we have vertical angles. This is vertical to this angle. So this is also 45. So that's how this came to be. Or if you don't want to solve that, just remember this angle of N from the horizontal is always the complementary angle to do whatever this angle theta is. So 90 minus 45. So this 45. Okay. Next, how about this? F has the same slope as your incline, so this is also 45. Okay, there, that's your complete free body diagram. So you can do this one of two ways. One is just to solve this as is, or method two is to rotate your axis, meaning choosing one of these forces as your X or Y axis. Okay, so later on we'll do that. But first, let's choose method one, which is using this as is. Okay, so the goal is to solve for P, but there's a lot of unknowns here. So instead of starting with summation of forces X, where P is, let's start with summation of forces Y. Okay. Okay. Summation of forces y equals 0. So n is upward, so positive n. Vertical component is sine 45. This is downward, so negative f sine 45. This is downward, minus 2 to 25. There's no other vertical force, so equate that to 0. Now, this is just impending motion. So the equation for F is mu s times n. So we can sub that, n sine 45 minus mu s n sine 45 minus 2 to 25 equals 0. Okay? What's mu s? 0.25. Okay, so now just sub that. So we can factor out n here. So n times sine 45 minus mu s is 0.25. Sine 45 minus 2225 equals 0. Then from this, you can solve for n. If you solve for n, you should get 4195.50. Okay, now you're done with that. Move on to summation of forces x equals 0. Okay, p is to the right, so p, n is to the left, so negative n, cosine, or horizontal component, 45. F is also to the left, so negative f, cosine 45 equals 0. And once again, F is mu n. So mu s n cosine 45 equals 0. N is 4195. Okay, store that. Okay, mu s is 0.25. So we can solve for P. Solving for P, you should get 3,708.33 newtons. Okay, there. So that's part A. Okay. Okay, so that's part A. Part A done. Let's move on to part B. It's part B. Prevent motion down the incline. Now we have a new free body diagram. The difference from A and B. A is impending motion upward. B is motion downward. So that means the difference would be the direction of F. Okay? So again, motion is downward for part B. F is opposing that. So now F is upward. There. Okay? That's the only difference. Then now, same thing, create your equations. So let's start with summation of forces y equals 0. So n sine 45 plus plus F sine 45 minus 2, 2, 2, 5 equals 0. Once again, F is mu n. It's still not moving, right? Preventing motion down the incline. So again, since it's preventing, it's not moving yet. So we're still using mu s. And sine 45 minus 2, 2, 2, 5 equals 0. Mu s is 0.25. We can solve for n here. I'm not gonna go through this anymore, okay? So n is 2,517.30. Then afterwards, summation of forces x. Okay, p to the right. So p, n is to the left, so negative n cosine 45. F is to the right, so plus n cosine 45 of f. Cosine 45 equals 0. Right? As you can see, the only difference is the sign. And then once again, F is mu n. You already know what n is. So 4. Sub that here. You can solve for P. So P is 1335 Newton. Okay. That's B. And then lastly, letter C. If P is 1780, what is the amount and direction of the friction force? Okay, so P is 1780. So again, we have a given force. The question is amount and direction of the friction force. So to get direction, what is the difference in equations for A and B? So the only difference is in the direction of F, because one is moving upward, the other is moving downward, right? So here, if we do summation of forces X to the left, so negative. While here in letter B, this is to the right, so now it's positive. Same thing with summation of forces Y. This is downward, therefore this is negative. Here in part B, again, F is upward, so that's positive. So analysis is the same. Okay. The difference is the direction of your friction force. Okay, gets understood? Or okay, great. It's continuing. Again, the goal is to get direction and magnitude of F. To get direction, we'll use this concept, angle of friction. Okay, so let's solve for phi. Phi is arctangent mu. And we know mu is 0.25. Solving for arctangent 25, it's 14.04 degrees. And theta is 45. So therefore, theta is greater than phi. And what happens when theta is greater than phi? It slides down. So that's the direction. Slides down. That's the direction of your object. So now that we know it slides down, The free body diagram that we'll use is this. Okay? Because it's the same as letter B. Letter B, again, motion is sliding up. Ano? Sa dalawa yung sliding. A. A. Not B. Okay. So, part B, part B is sliding down the incline. And part C, we solved that it's also sliding down the incline. I'm gonna use this. Okay. However, to make things easier for me, the only goal here is to solve for F. Okay. So if I'm gonna do this normally, I'll go through this equation again. Just to make things shorter, instead of having this as my free body diagram, I'm gonna rotate this so that F is now on the x-axis. Okay. Then F is on the x-axis. I don't need these angles anymore. To get x on the x-axis, we just rotated clockwise by 45 degrees. Therefore, okay, imagine P rotated clockwise 45 degrees. Therefore, this angle is 45. Same thing here. 2225 was rotated clockwise by 45 degrees. So this is 45. But again, the only angle that I want is from the horizontal. So 90 minus 45, this is 45. Okay? I don't need. So there. Now, why did I do this? So that if I do summation of forces x equals 0, I'm not going to go through n anymore. Okay? Let's start p to the right, so positive p cosine 45. We also have this to the left, so negative 2225 cosine 45 plus f equals 0. As you can see, equation is much shorter. Okay, and then P is 1780. Okay, so F is equal to 314.66 Newton. And since your object slides down, friction opposes that. So the direction of your friction can either draw the arrow or right upward. There, that's number 1. Any questions for number 1? Please answer in the chat. Okay, since you don't have any questions, let's move on to number 2, or a portion of number 2. So number 2, the blocks shown in the figure are connected by flexible, inextensible cords passing over frictionless pulleys. Okay, so you have these 2 blocks, and you have 2 frictionless pulleys. So that's the system. At A, the coefficients of frictions are 0.3 and 0.2, while at B, they are 0.4 and 0.3. Compute the magnitude and direction of the friction force acting on each block. Okay, so we have 2 blocks, and the goal is to get the friction force for each. Now that sounds easy, but in actual, it's a bit complicated. Okay, how come? Well, let's start first with writing out our given. Okay, so for block A, let's call that mu SA. That is equal to 0.3. Then its coefficient of kinetic friction is 0.2, right? And then coefficient of static friction for block B, let's call that mu SB, 0.4. And then kinetic is 0.3. Okay, so first of all, before we solve, we need to know what direction is this moving, okay? Now, sometimes you can figure it out just by inspection, right? So how? So sometimes, let's say you have this system. Let's say this is 100 pounds, this is 50. So just by inspection, the only movement that this system can have is downward or stationary. Impossible to move to the left. Okay, so that's one by inspection. Another is having two equal slopes. So they're equal slopes. Again, you have your pulley. Again, this is 100, this is 50. Since they're equal slope, let's say equal slope, the tendency of this system is to move downward, like this, because this is the heavier one. Okay? So those are examples wherein you can figure out the motion just by inspecting. Now, unfortunately, for problem number 2, that's not the case. First of all, they have different slopes. Okay? This one is steeper. Okay? Usually the steeper slope has more chances of having that motion along its slope. However, block A, it's heavier than block B. So it's not easy to just observe what's happening. So to figure out what is the motion, you're gonna ignore friction. Okay. So this is what we'll do first. Assume frictionless to get motion. Okay. So that means we're gonna ignore friction in this body. Now the next step is to find the path of your motion. So the path of your motion is this way. Now what you're gonna do is you're gonna get summation of forces for each block along that path of motion. So again, this is the path of motion here, right? And this is the path of motion here. Okay, so let's start with block A. Draw your free body diagram. So this is 3, 4, 5. Okay, and then we have weight here downward, which is 3,000 Newton. Then we have tension here. Let's call that tension A. Then what else do we have? We have normal force here, right? As well as here. So NA here, perpendicular. So that's our free body diagram. Next step is to figure out slope since we're not given angle. Now, usually, right, when we have systems involving pulleys and cords, okay, the resultant of this motion would be equal to the tension because this tension will carry the entire force on the opposite side. Okay. So again, the tendency of this motion is to go here to negate that or to counter that. We have this tension. Okay. So whatever the value of tension is, That is also the magnitude of the total or resultant force along the motion. Okay, so in short, the goal is to get the value of tension. So to get the value of tension, I'm gonna rotate my axis because as you can see, or as you've seen earlier, if I rotated it, the solution is shorter. So I'm gonna write that here. So just as a reminder, this is my x-axis, this is my y-axis, okay? So I'm not gonna physically rotate it anymore. Now, if that's the case, if this is my x and y-axis, this 3,000 Newton force is at an angle. So now I need to know what that angle is. So to get that, yeah, to make things easier for us, just know this is where that line is, right? Okay. We're gonna do your theorem on angles again to figure out what this angle is. Now, if I draw a straight line here and this, I can get this slope, which is the same here, okay? Now, this line, if I draw another straight line here, this line perpendicular to this line, right? Yeah. And then this line perpendicular to this line. So whatever is the opposite, it's the same. Opposite of this angle is 3. Therefore, the opposite of this angle should be 3 as well. Okay, so that's it. So the opposite is 3. Therefore, the other leg is 4, and then this is 5. You don't want to go through that again. It's just the opposite. Here, the base is 4. On the other one, the base is 3. Okay, so now you have your slope. You can create your equations. So we're solving for TA. So that's summation forces x. That's your Rx for just TA. So TA is equal to the x component of your weight. So that's 3,000. X component is this 3 times 3 over 5. That's equal to 1,800 Newton. Now that you have that, okay, move on to block B. Now for block B, same thing, okay. So this is, once again, 3, 4, 5. We have this, and then this is your 2,000 Newton force, and then tension B, right? And then normal force perpendicular to that. So let's call that NB. And then again, this is my axis. I'll choose N as my x-axis. And then this is my y. X, y. Again, the goal is to get TB. So to get TB now, I need the slope of this. And to get the slope of that is just the opposite of this. So here, base 3. So here, this is your base. Yeah, base 3. Here, it's your height 3. Base 4, hypotenuse 5. Okay, again, it's just the opposite of your original slope. So TB is the, or in this case, the vertical component, the component parallel to your tangent. So that's 2,000 parallel to your tangent. This is your tangent. Parallel side is this, so that's 4 over 5. So equate that, you get 1,600. Now we're not done. Look here. Since our system is not simply a pulley and then your blocks, if that's the case, you're going to compare these two now. Whichever is greater, that is the direction where your block will move. Now, unfortunately, again, our problem is a bit more complicated than that. We have this system. So you can create another free body diagram out of that. So you have this pulley. Okay. Obviously, this is your tension B, right? It's this wire. Now, how about these two? So this is TA passing through here. So meaning this is also TA. Member frictionless pulleys just carry the same tension. Now same thing, it passes through this pulley and goes out here. So that means this is also TA. Okay, so from this free body diagram, we can say we're gonna compare TB to twice TA. And obviously, this is TA. Twice TA is greater than TB, right? Therefore, it's gonna move along the direction of TA, which is to the left. Okay, I'm gonna end it there. This is just figuring out where your body will move. So again, usually you're just gonna compare TA to TB. That's done. However, again, here we have a different system of pulleys. You're gonna choose the pulley that has both your tension, TA and TB. So that's this pulley right here, create free body diagram. So here, as you can see, we're comparing twice TA to TB. Twice TA is greater than TB. So that is where our object will move. And TA is to the left. Okay? So I'm going to continue this Tuesday. Okay. So a few reminders before I dismiss you once again. Exam on Saturday. Quiz open. Okay. So on Saturday, I won't be able to meet with you guys. So there's no Zoom meeting. Okay, there's no Zoom meeting this Saturday. Answer it. However, our class, you can only answer it within our class time. So it's only still from 12 to 1:30. Okay? That is the only time your exam will be open. So no Zoom meeting, but schedule is the same. Coverage is only until method of members. Friction not included. Okay? Once again, no Zoom meeting on Saturday, but still schedule is the same, 12 to 1:30. You still have to finish your exam by 1:30. Upload your solution by the end of the day. Okay? Any questions? Hindi kasama ang equilibrium of non-concurrent forces. So the only things that are included are method of joint, section, and members. Okay? Any other questions? No more? By the way, you've already finished your final grade if you've seen it. Final grade is module MG M grade 1. Okay, so if you're IP or not, you'll decide if you answer IP exam. IP exam is already up. So for those who got an IP, please answer IP exam. Again, it's at the bottom tab below Panopto. Okay, so you have until the end of the term to answer your IP exam. All right? Do you have any questions, clarification, since you won't meet on Saturday? Yes, pati yung mga I and IP will take the IP exam. Exam or quiz, they're the same. Okay, exam, quiz and exam are the same to me. So quiz on Saturday, coverage, method of joint sections members. Modular exam next week, which is different. Okay? Any other clarifications? Lana? Okay, again, for the last time. Quiz number 2 on Saturday, no Zoom meeting, 12 to 1:30 schedule is the same. Right? Also, in the event that I'm not gonna have multiple choice, because I'm still deciding, this is the format of your answer if we're asking for compression or tension. So let's say 10.01 space unit space parenthesis C or T parenthesis. Okay? Or 20 if it's a whole number space kilonewton space tension. Okay, so that's the formatting of your answer. Small or capital letter doesn't matter. It's gonna be the same answer. Okay. Capitalization is not on. They're not considered. So either small or capital is the same. Okay. So this can be the yes. Yes.
I-upload niyo po ba yung solution nung nakaraan na seatwork?
It work. Oh, there's still some people who haven't answered the seat work, so I'm still waiting for them to finish. Once
Okay.
they've answered, that's when I'll upload. Okay?
Okay. Thank you po.
You're welcome. So it's time. See you next week, Tuesday. Goodbye, class.
Thank you po, ma'am.
Thank you, ma'am.
Thank you po, ma'am.
Thank you, ma'am.